Well, g'day, Year 7s. That's actually becoming a bit of a catchphrase, isn't it? I was thinking that the other day. Got to come up with something a little bit more original. Anyway, look, today we're looking at angles again, but we're looking at angles specifically in relationship to parallel lines. Okay? Now, these learning intentions are going to sound really difficult, but it's just a bunch of complicated words that are actually quite easy to understand. We're going to look at them just over about 5 or 6 slides actually, so don't be put off right from the beginning, okay? So here are our learning intentions. We want to, by the end of this, well, by the end of the exercises at least, try to understand what corresponding, alternate, co-interior, co-exterior and adjacent angles are, and we want to be able to use these to solve maths problems. We also want to understand the importance of whether lines are parallel or not when it comes to solving the problems stated above. Okay. Now, that probably didn't mean much. Doesn't matter, we'll just move on. Okay, so here we go. Now, we want to begin with parallel lines. Now, this is something you'll all be familiar with, but I'm going to define it anyway. So parallel lines are two lines that do not intersect or touch each other at any point. Now, it's a bit more significant than that. You've got to imagine these two lines being infinitely long. And even though they're infinitely long, they will still never intersect. Because let's just say that red line at the top there, let's just say that was just angled down by 0.00000, a million zeros, and then a 1 degrees. Eventually, if you go along the number line, not the number line, if you go along that red line, it's eventually going to intersect with the green line, okay? So, parallel lines, you've got to imagine two infinitely long lines, and because they're infinitely long and they do not intersect, that means that they are parallel. That is the proper definition, okay? All right. Now, that's something you would have known already. But what is a transversal? Okay. Well, a transversal is a line that intersects two parallel lines, okay? So when you have a pair of lines that are parallel, and by the way, these two little arrows here, those don't mean that these two lines here are necessarily the same length. They might be the same length, it looks like they are, but that's not what those two arrows mean. Those two arrows mean that they're parallel, okay? And any line that crosses through two parallel lines is called a transversal, okay? All right, a couple of other concepts. One which is just a rehash of something we've done already. So here we have vertically opposite angles, okay, which arise when you have two lines that do intersect. So they're obviously not parallel. And vertically opposite angles are always equal. So 1 equals 2, 4 equals 3. And in the previous slideshow that we did, we had, I think, A equals B and C equals D or something like that, okay? So we've already dealt with that. Something we haven't dealt with is the word adjacent. Now, we all know that adjacent means next to. I'm sitting adjacent to Stephen, means I'm sitting right next to Stephen, okay? It has a bit more of a specific meaning, even though it's related to that idea in mathematics when it comes to angles. So two angles are adjacent when they have, and here are the conditions, when they have the same side and the same vertex and they don't overlap. Okay, so the two angles can't overlap. The main thing to remember is that they have to have the same side and they have to have the same vertex. Or they have to share a side and share a vertex. And they cannot overlap. It's against the rules. Okay. All right, so here we have some examples. Now, here we have two angles, A and B. Now, these are adjacent. Why are they adjacent? Because they share a vertex and a side. So an edge. or a ray or a line. So many words for these things. Okay, so this is the vertex that they both share, and this is the side that they both share. So they're adjacent. These two are clearly not adjacent because although they share a vertex, they don't have a line in common, or a ray, or an edge, depending on what word you want to use. Here, what do we got? This one's a little bit funnier to think about. These are not adjacent because although A and B share a side, they do not share a common vertex. So a point, a corner. They don't share this corner and they don't share this corner. So they're not adjacent. And this is the special case, okay? They cannot overlap. So A is overlapped by B. So A and B are not adjacent. So adjacent angles, we're really looking at scenarios like this here, okay? All right. So we've talked about parallel lines and a transversal, which is a line that crosses two parallel lines. So we have different situations that arise where we have relationships between angles in this situation, okay? And they've all got different names. So there's 4 that I want you to remember, okay? Firstly, corresponding angles. So corresponding angles occur when you have a transversal, so a line that goes through 2 parallel lines, and you have an A and you have a B, okay, and they are both on the same side of the parallel lines. So this is on the bottom of the first parallel line, and the B is also on the bottom of the second parallel line. They're both on the bottom, okay? If B was actually in here on the top of this parallel line, and A was also on top of this parallel line, then they would also be called corresponding angles. But they have to be on both on the right-hand side or both on the left-hand side of the transversal, okay? And as you can actually kind of tell, they look the same size, don't they? They're equal. They're equal in size. So if you know that A is, say, 25 degrees, then you know that B is 25 degrees. Well, what about alternate angles? Well, that's quite easy because they're on alternate sides. See? Alternate sides. Simple as that. If it was here, your B, and your A was here as well, okay, then they would also be called alternate angles. And alternate angles are also equal to one another. So if you know one, you automatically know the other. Co-interior angles. All right. Now, if you have a transversal that intersects 2 parallel lines, like we have here, and then you have 2 angles that are both inside of those parallel lines and on the same side of the transversal, then those 2 angles are referred to as co-interior angles, okay? They are not equal, however, they are supplementary. And remember what that means. That means that when you add them together, you will always get 180 degrees. Should have a degree symbol there. I apologize. Okay? So corresponding angles, alternate angles, and co-interior angles. Now we have one more. All right. So if you understand co-interior angles, then you're going to quite simply, it's going to be quite simple for you to understand what a co-exterior angle is, okay? So if my B was here and my A was here, they would be co-interior angles, all right? Co-exterior angles simply means the 2 angles are on the same side of the traversal, both on the right or both on the left, okay? But one is above the top ray or line, and the other is below it. Okay, so they're exterior. All right, so a couple of examples here just to finish us off. State the name of the angles below and find the value of the pronumeral. Remember, pronumeral basically means the same thing as variable. It doesn't have the identical definition. They're not exactly the same in their definitions, but more or less the same. Okay, so state the name of the angles below and find the value of the pronumeral or the variable. All right, so first example here. Well, they're both on the same side of the transversal and they're both interior to the parallel lines. So that's an example of co-interior angles, okay? And we learnt that co-interior angles, that's one of these examples where they're not actually equal to one another, but they are supplementary, which means if you add them together, you're going to get 180 degrees. All right. So if I know one of them and I want to know the other, all I have to do is say M, in this case, equals 180, because once added together, they equal 180 degrees, minus, and excuse me, the cursor keeps disappearing for some reason. I'll fix that before the next video. 180 degrees minus 45 degrees, which equals 135 degrees. Simple as that, okay? And another example over here. So again, let's restate the question. State the name of the angles first and then the value of the pronumeral. Well, what is the name of the pair of angles? Well, they're corresponding because they're on the same side of the transversal, okay? But they're not co-interior. They're not both on the inside. And they're not co-exterior, they're not both on the outside. We've got one on the inside and then one on the outside. And you can see that these angles here, just by looking at them, are the same size, okay? And the rule there is that corresponding angles are always equal, they're always the same. So if that's 52 degrees and we're asked to find x, well, simple answer is x equals 52 degrees. That's pretty good, eh? No setting out. All right, guys. So just using those few rules, you're going to start doing some exercises, starting off really simply, and then you're going to build up to a couple of questions that get a bit harder, where you have to do a couple of different calculations before you can end up finding the value of the pronumeral. But those questions, if you look at the home learning schedule, I've put at the end as optional. But if you get the time, have a crack at least at some of them, okay? Because it's really good practice for next year. Alright guys, that's our last video for this week. Thank you for listening, and I'll see you next time.